Hey everybody, it's Norm from Tested. So recently I got to go hands-on and learn about Google Stadia. If you haven't heard about this, this is Google's upcoming gaming platform. It's not exactly a console, it's their take on cloud gaming. That's right, the game is rendered on their data centers and then streamed over to your phone if you have a Pixel 3a, or over a Chromecast to your TV. They're launching it next month. There's a bunch of titles that they've worked with to support it. I got a chance to play Mortal Kombat 11 and then sit down with two of Stadia's VPs to talk about not only the product but also the technology that makes cloud streaming possible. I think it's really interesting. Let's take a listen.
I'm John Justice. I run the product team, so deciding what we're making and for whom.
Hi, my name is Majd Bakar. I run an engineering team, and I've been with Stadia since day one.
So what does day one mean? How long has Google been working on Stadia, even in its infancy?
Yeah, so we started Stadia around like 2013, 2014. There were a lot of effort in the company around gaming and cloud gaming. But in 2013, we launched a streaming device called Chromecast. And we brought movies, TV shows, and music to the living rooms through that device. And the next natural thing to bring is gaming. Now, this is a very, very low-powered device. So how do you bring high-end gaming to that? And the obvious answer for us was immediately cloud streaming. And given Google's infrastructure and all the tech that we've invested in streaming video, can we apply this to gaming? And this is how it came about. So we collected all the different groups that were working around this topic, put them all under one roof, and we started Stadia then.
I mean, the idea of cloud gaming, it's not exactly new. A couple companies have tried very famously, OnLive about a decade ago. Yep. And maybe for one reason or another, the infrastructure in the United States wasn't necessarily there, or the technologies for compression, or even the market where people were used to. But we feel like the momentum growing on that, and you guys seem to think about it very early.
Yeah, I mean,
what makes now the right time for it, I guess?
We have to give homage to OnLive. They are the pioneer in this, and they started in 2010. I think they might have been a bit early for the time, both in terms of the infrastructure, as you mentioned, but also the technology, in terms of all the encoding technology, the codec that allowed for very good compression at good quality, but very low latency, as well as how do you distribute real-time interactive application over the public internet. So all of that has been work in progress for the last 10 years, happening at different areas, whether it is in terms of Hangout and real-time messaging, or in terms of YouTube and just streaming high-quality video to users. So that combined with the infrastructure, where as of now, the latest report from the FCC says 80% of the US households can have access to 1 gigabit per second internet connectivity. That wasn't the case in 2010.
Right, and that's far above the minimum spec you're talking about right now.
Yeah, and this is something that a lot of people have done runs at over the years. Well, much newer to Google than Maj, worked on cloud gaming for years at other spots. And it's one of those things that you have to wait until there are enough people with good connections and that you really have a network with the quality that Google has. Google has a fantastic network. We built it out for making search results super fast and making YouTube connections super fast. And so building on that lets you go have better connections to people than what anyone else can do in the world.
And you mentioned all these other services that Google works on, from YouTube to Hangout, and things that kind of lay the foundation for what makes Stadia possible. In terms of the tech, the experience, from the user experience side, there seems to be two aspects people are going to be most concerned about. One, image quality in compression, and two, latency or responsiveness. I want to talk about both of those things from a. And I know they're related to each other for sure, but like from a compression standpoint, my understanding this piggybacks off of what you've been doing with on the VP9 codec on the YouTube side and integrating that with all the browsers in Chrome, right?
Yeah, so I mean, Google has been investing in the VPX codec line since we bought onto a while ago, I don't remember, 2012 or 2010. And with VP8, VP9, and now AV1, and potentially the future codec, we've been focusing on how do you get the best quality at the lowest bit rate while maintaining also that ability to encode in real time. I mean, the concept of Stadia is you have the game rendering frames on the GPU at 60 frames per second, And every time there's a new frame on the GPU, we capture that, encode it, and send it over the wire. Right. So we invested in that technology in general, but then for Stadia, we have our own systems that allow us to have enough processing power and enough tuning that we can encode every frame in sub-millisecond. So we reduce that latency further and be able to distribute the interactive experience to users.
So you want, from a quality perspective, you want a very efficient codec and also a very fast codec. Both of those, do they come at trade-offs?
Yes, of course. The higher quality that you need, the longer that you take. For example, when you look at Netflix or YouTube 4K content, it is at higher quality. They do multiple passes, and this is what we call offline encoding, which usually happens to encode a 1 hour worth of movie, it might take 3 hours. In our case, it's the other way. To encode 1 second or 1 millisecond of 16 milliseconds of content, we need to take way less than that. We need to take 1 millisecond. So being able to build enough intelligence and leveraging all the Google knowledge and know-how of how to optimize between high quality and low time to encode, that's what we've been spending time on over the last few years. And this is where we did our optimization. We also built specialized hardware that allow us to do that.
And then the specialized hardware, when you're talking about GPUs, essentially these are reworked versions of PC copies of the games. Is that correct? Or
no, that's not the right way to look at it. Instead, I think about it as, for any of the platforms that you might move to, you might just do ports for somebody to take something and they just kind of port it over, tiny little changes. For us, we're looking for native versions for Stadia. And so people go take, they either writing something fresh for something that's brand new, or they're going and they're changing it pretty significantly to make it work really well with our systems. We take advantage of that for latency, because the better information we know about what's going on in the game, the better we can go run things quickly, we can go do things faster in the cloud than what you could do in somebody's console in the home. There are different features that we take advantage of, like connecting things into YouTube or the other, or into Assistant and kinds of things there. But all of that takes a version of the game that really is custom for Stadia. And so we work with developers. We've been working with a lot of them for a long time to get their games ready. And then now we have a whole lot that are currently in progress for the next batch.
So it really is a onboarding process, part of the planning as you guys have been leading up to this rollout. It's not going to be, again, a trade-off where you could have made it easy, but the user experience wouldn't have been as ideal, or you wouldn't have much of the features. As you
we want to give the user the best experience that they can imagine, and getting it through Stadia.
I mean, you have all this processing power, you have all these servers, you can do as much as you can on the server side to minimize the latency and have the best quality, but it's always going to rely on the user connection and also the device they're using. So let's talk about that part of it, right? Where does most of the latency come in? Between a Wi-Fi connection or broadband home connection, where is that latency?
So typical latency is really 3 parts. You have stuff that are generic to all games. In the game itself, whenever you take an action, the game needs to do some processing before it decides what to do as a reaction. There is the ability to encode and stream each frame, and this is where we spend a lot of time on optimizing this. And then once you get it on the client, the ability to decode and present that frame to the client and collect input from the client. And this is where we worked on the Chromecast firmware to ensure that we have the lowest latency there, as well as on the Android phones. So Pixel phones are optimized for that low-level latency. And building our controller, which is a Wi-Fi enabled controller that allow you to send the command to the server, which is where it will be interpreted in very, very low latency mode. But you still we can't travel faster than the speed of light. Sure. So there's still that networking aspect of it. So the way we accommodate that is by giving the game enough insight about what's happening and enough timing about when the user saw an action and when they took an action, saw a frame and when they took an action, and how they can correlate that together. Also, we give them the ability to run at a faster refresh rate. So rather than running at 60 frames per second, they would run at 120 frames per second, which means they're running the game faster because we have more processing power, which means they can process the information faster. So that allows us to regain some of that latency.
Even though you're only displaying at 60, the data, the input, okay.
And there are also other techniques that we are looking at in the future in terms of either late frame reprojection or late latching that allow us also to capture much of that latency that we cannot overcome in terms of network. And still, the end result to the user is there is no latency.
Yeah, there's a common misconception people will ask about, well, isn't the internet, the speed of light, you can't go faster than the speed of light, but we're running through the fiber lines that we go through, you run about 0.7C, so you get about 210 kilometers per millisecond. Like that's pretty far actually for speed of light. Speed of light's not the thing. You have routers that aren't configured well, you have the different hops, and then you've got to go along the way that you can optimize those paths. And when you've got a core game loop that might take 50 milliseconds, it might take 150 milliseconds on some games, there's a lot you can do on the server to just do that faster. And so you can easily get back the milliseconds that you need to make up in transmitting the data with basically just a longer cord. So it's actually not that big of a trade-off, and speed of light just isn't the blocker when you get into cloud gaming.
And you're minimizing all the variables of the protocols and the user side unknowns by having things like the controller directly connected to Wi-Fi, going right to the data centers, seeding data centers around the country, that last mile being the most important.
That's actually, thank you for bringing it up. That's a very important point. I mean, this is why Google is very uniquely positioned for that. We've been investing in our data centers network for the last 18 years. We have 7,500 edge points of presence that we can leverage, being very, very close to users. So what John was talking about, that 0.7C, or that ability to travel at the electron traveling at almost the speed of light, that's by pushing those servers closer to users, you are reducing that latency further.
I mean, using the analogy of like Netflix video or streaming video in general, they can create buffers, right? Which you can't, because you can't create a buffer because the user needs to give you an input. But you also mentioned doing things like some type of prediction. And I've read stories of how you guys have thought of ways to either use machine learning or use data or capture higher refresh rates than what people are seeing to do things like reprojection. How does that work, and what benefit do you actually see from that?
And the benefit we see is in being able to recover that latency buffer that is in the network. Now, we're not going to have all of these on day one of launch. These are technologies that take time to develop and take time to integrate in games. But they've been proven in other parts, like for example, VR uses that extensively. And learning from VR, bringing it back into cloud streaming is definitely helpful. The ability to run the game at a faster rate, that actually has been in existence for a while. We're not the first to do it. But doing it at the scale that we are looking at and being able to deliver that experience is going to result in a better user experience. That's
a really interesting analogy. You talk about VR, because I understand that concept where input happens at a much higher refresh rate than display, even though for those systems are like 90 hertz or so. You're using the same analogy where you're displaying at 60 frames, but you can have input, or you can do things to fill in some data and anticipate what people might see.
There's some piece of that, but we talk about all of the techniques that we use to run it faster as things that are in this kind of negative latency bucket. But you think of it, just running the game loop in a faster time because you have a monster system you're running it on, that's not magic, that's not rocket surgery. That's a thing that it kind of, you can get your head around and make sense. Some of the techniques are fancier, like Maj mentioned, late stage reprojection that come from VR. The idea that you can go apply some corrections later in the pipeline after the standard rendering happens, later on, to just do tiny tweaks that are visually imperceptible, but let you go correct for tiny changes that you get late in the pipeline. That's something that happens a lot in VR that you can actually apply it to games here. And so it's a really great thing. You've also got things like, I look at the way multiplayer networking works. There's, most games are designed with two forms. It's either something called dead reckoning or something called rollback, if you're really doing something that has great interactivity. Because we can go run systems really close to each other with really low latency in the cloud, we can go make that connection between them so fast that we can make multiplayer much, much better when running out of the cloud than you can ever do running at home, where often someone with their console or their PC, they get elected as the leader of this thing. Yeah, and when you got host advantage, you have lag switches, you have a bunch of things that get in the way. And so instead of everyone depending on the one connection that gets picked and let's hope it's really good, you instead have these things that are sitting, a millisecond away from each other. And so you can go have just really good synchronization. So the multiplayer gets a lot better. And then you can take some of the techniques that are used in, like, say, fighting games. If you're playing Mortal Kombat, they do rollback that lets you go immediately see reactions from your player, and then imperceptibly there are adjustments that are made. It makes it feel great. And rollback's been known for a while. There's the GGPO kind of middleware that's been out there in the world used by lots of fighting games. A lot of those techniques you can apply even when you're just playing a regular game. And so it's a batch of techniques that you go use to either run things faster or otherwise claim some milliseconds that let you go run really, really quickly.
I love, again, that late-stage reprojection analogy. I'm trying to put a real example. Would you mean, for example, if someone was panning a camera around, right? And
kind of like you're turning your like in a VR thing, like you're turning your head, and there's some level of the frame gets rendered for a point of view, and then maybe you turned it a little bit more after the frame was rendered. Late-stage work actually can go slightly correct. Without fully re-rendering the frame, it can slightly reflect it, like do kind of a parallax sort of effect. And so you can get it to be smooth even though that change happened a little bit late in the pipeline. And so there are a bunch of techniques like that were pioneered actually in VR that you can then apply to regular games.
But the whole point is that this should be imperceptible to the user.
The user doesn't even know about it, and they shouldn't know about that. And to some extent, we are doing it at as many as we can on the platform level. So even developer don't need to do any work, but sometimes it's not possible. They do need to do so.
How much extra info in your collaboration with developers do you get out of, when they tap into the SDK, and like what extra game input do you get?
I mean, it depends on who they are, what they're doing, and let's see. We'll get information about. Well, you already get a ton of information just based on what's going on in the frame. And so if you think about something like video encoding, Maj mentioned about how you have to do it differently to do it in single digit or do it in a millisecond. Like you can't do forward-looking and backward-looking kinds of P and B frames that you'd normally do in encoding of static content. But we also have access to, hey, what's going on in the engine? And so we know what's happening in the scene, we know which direction you're turning, we know what's happening there. And so that's information that's just available because we're running the game. So there's a lot of stuff that we just get access to because we're running the system there. And so we can make smarter decisions about the video stream because of that.
And your partnerships on the engine level as well, so that those benefits trickle down?
We work with, obviously, Unity and Epic for Unreal Engine, but also all the big publishers or developers that work with us, we work with them on integrating Stadia into their engine. So once they have it in the engine, future games will get it for free.
I mean, all of this stuff is a lot of technology, but eventually it's to get parity or some benefits over the dedicated console model. But it is going to be a subscription model. So from a value proposition, what are you trying to message to gamers as the benefit for paying a subscription and then buying games after the fact too?
Actually, you can look at it as there's the base of the system, the hardware, all of that stuff that we're going to keep upgraded, and it's a lot more powerful than any console you can buy. All of that stuff we're just giving to you. And so that's something that's out there, and so you can just get games, run them on top of that, that'll be fine. The subscription that we're doing on top, that's going to be an optional thing. So you can think of it like a lot like PlayStation Plus or Xbox Live Gold. It's extra features and some games on top of that. But we see that as optional. And so that brings you things like 4K. So if you want to go run it full 4K, that's an optional thing that's on top. Games every month, and then on top of that, we'll have some discounts and things along with it.
And you said feature sets are things that are going to be rolled out, after launch, things that you guys have been working on.
Absolutely. I mean, you should think this is a different model than having either a hardware that sits under your TV or a disk that is burnt at production time. It's an evolving platform. We are going to run it as a service that will always keep evolving, keep enhancing, and will keep providing new features and functionalities to our users.
I mean, certainly it's not the biggest part of the gamer audience, but there is a core part of the gamer audience that loves the idea of going back to old games or old versions and preserving the history. Is that something you think about? Like, is going to be a possibility to say,
classic games?
Yeah, absolutely. Is there a way to, like, I want to load the pre-patch version of this, or load the own map, or compatibility modes? How do you think about that in Stadia?
Well, one on the kind of classic games and game preservation, I think this is an incredible opportunity. You look, it's hard to even find the way to run your old systems now. Like, I've got old systems around at my house. They don't always turn on. Sometimes I got to go repair them. So I really want to have access to those classic games. And so I think over time, this will be a great kind of place for it. It's something I'm really excited about. And then getting into how I can, like, modify the game, how I can do things like mods, those sorts of things. I think that's a really interesting thing. So it's something that we're spending a lot of time thinking about. We don't have anything to announce here on it yet, but it's something that, a lot of us play games with mods today, and I think those communities are really great additions to the game. So we want to find a good way to do it, and a good way where we can let people have mods in a way that is kind of safe for folks that are out there. There are a lot of things, if you get content that comes in from different spots, you have to make sure that what's exposed to different people is something that's that you actually want to get behind. So we're doing the work for making sure that both the content can be run kind of within the right sort of sandbox, and then we have to make sure we got the right user access model. But it's something that we're already thinking about.
And then you guys are building your own content teams, and you have studio in house. As they're working on content, what do you think is what's the killer app for Stadia? Is it something that is a AAA equivalent on existing platform, or is it something that's completely different that does take advantage of technologies that you've built up?
I mean, the key differentiation is going to be how to showcase the power of Stadia and the power of cloud streaming. So building games. They will be AAA games, very high-end games, but building games that showcase what is so different about cloud streaming, whether it is in showcasing that YouTube Stadia loop that we talk about, viewership and gameplay, or leveraging our ML infrastructure and being able to have characters that feel very real, or interact with you through natural interaction, natural language, or natural interfaces. That's a better question for Jade Raymond, who runs our SG&E, but definitely this is an area where we feel our first party studios is going to shine.
And it's just launching, this year, but the hope is that it'll be an enduring platform. It won't, people.
Absolutely.
We not only have games in development for the next many, many years, and along with that, how many generations of hardware are already in flight right now? Because we're Google, we go and continually upgrade our hardware, and so we're already working on several years in advance of the kinds of upgrades that we're rolling out.
Yeah, I mean, from a technology perspective, we already have a at least 5-year roadmap on the technology. But when we look at Stadia, this is a long-term investment for us. It's not something that we are looking at the next 2 to 3 years. This is a 10-year or more project, and we're definitely looking for it for the long term.
That's very exciting. Can't wait to see gamers actually play this. Yeah. And thank you both so much.
Thank you very much.
Thank you.
So I found that super interesting, especially when they're talking and deep diving into the compression technologies and all the things they can do on the back end to make this kind of dream of streaming a game with very low latency possible. Now, as a product, there's still a lot of questions that we don't have answered. Even with the hands-on time that I got with Mortal Kombat, I was playing this on what could possibly the best case scenario. It was literally in Google's headquarters. Who knows how far their data centers are to the headquarters? I'm betting pretty close. It was on their hardware, and it was on a game that, while you do need quick responses, and I didn't notice any latency, it's not as twitchy as, say, a first-person shooter. So you gotta take my impressions with a little bit of grain of salt, because we'll have to wait till the full Stadia package comes out on November 19th before we can really put this service through its paces. But under the perfect conditions, it really felt like I was playing a console set in the room. On the TV, streaming at 4K 60 FPS with that 5.1 surround sound, it looked and sounded great. With the movements of Mortal Kombat characters, I couldn't see any noticeable compression the way they're doing it over their VP codec, and especially on the phone on 1080 on the Pixel 3a, it looked unbelievable. The phone wasn't getting hot. It was basically like it was streaming a YouTube video, except running the graphics and the fidelity that you couldn't run locally on phones or any type of mobile hardware today. Now, the product itself, there's still a bunch of unanswered questions. What Google has announced is that on November 19th, people who've paid for the Founders Edition of Stadia will start to get access. Now, the Founders Edition is different than what eventually will be what most people will be able to subscribe to, which is either the Pro Edition or the Standard Edition. With the Founders and the Pro, it's going to be about 3 months for free, but you will have to pay about $10 a month to get access to this, depending on where you are in the launch territories. And for that $10 a month, you don't necessarily get a bunch of free games. A lot of people pitch this as, is this like a Netflix all-you-can-eat buffet of game streaming? Not quite. They've announced Destiny 2 as one of the free games you'll be able to play, but essentially paying that $10 a month only then allows you to play that and then buy other games at traditional prices, $60 a game to buy things like Mortal Kombat 11 or Red Dead Redemption 2, and then you would own those games or own them or be able to stream them on things like your TV with the Chromecast Ultra or on mobile devices, starting with, at least for the foreseeable future, their Pixel phones. That's right, it's gonna be limited to Google hardware initially. The free tier for this, which would be limited to 1080p 60 FPS and only stereo surround sound, will be launching next year. And even with that free tier, again, you'd be buying up games. So the business model is very similar to that of traditional consoles. They want to work with publishers and make sure the publishers are getting their cut. Not speak of the internal games that Google is spending a bunch of money making on their own. As a gamer, there is a little bit of an appeal to paying just for a controller, a $70 Stadia controller, or $130 for the Founders Edition, which gets you the Chromecast Ultra, and not spending $300 or $400 on a traditional game console and using that money to then buy games, but you are paying for a subscription service if you want the highest quality 4K 60 FPS. And while Google has promised that there will be some amount of free games to play, maybe classic games, maybe whatever deals they make with publishers, none of that is firmed up or announced yet. And the fact that right now the promise of that low latency is so bound to the controller sending a direct signal to the data servers over Wi-Fi as opposed to using Bluetooth to your TV console and then over the internet and then coming back, none of that is fully executed as well, either for launch. For the mobile side, you saw when I was playing it on the phone, it had a direct connection from the Stadia controller to the phone because the controller still needs to send data to the phone for now and then send it over to the cloud. In the future, if the promises are kept, the idea is that you would be able to play on your laptop with a plug-in controller, on your phone, or on your TV, and go from game to game to game. And in the demo I had, the switching between the devices was pretty seamless. It wasn't immediate. It did take a little bit of loading on the phone and then on the TV, but I got to continue where I was in the game in the middle of that fight while pausing the game from one device and the other. You won't be able to stream to two at the same time, of course. For a lot of people at the end of the day, assuming all this goes as planned, the data centers are in place, the latency is low, it's going to end up depending on their own home connections. Now, Google will say that 80% of the United States customers have access to very high bandwidth internet connections, up to a gigabit connections, and their minimum spec is only 35 megabits for their 4K streaming with their compression, or all you need is 10 megabits if you want 720. A lot of people, it's going to be about latency. What is latency going to be like on your phone or when you're on the go, when you don't have a max connection, or with all the added kind of infrastructure of your home internet, how far you are away from your telecom. All that stuff is going to compound. They're designing for the best case experience, which is what I got to try, but we'll have to wait till this comes out to see essentially what the standard user experience is going to be. And also, when the games come out, what are you going to be playing with? Is this going to be considered a PC game? Or are you going to be playing a multiplayer with other console gamers? Probably not on Xbox, probably not on PlayStation. They have their own walled garden networks. So right now, it's going to be, for me, a little bit more of a tough sell. I'll need to be convinced when this launches. It does come out though in just about a month, November 19th. We'll hopefully be getting review units, putting it through its paces, and we'll have more to share, more impressions, and more testing then. But hope you found that enjoyable. Thanks for watching, and we'll see you next time.